Now next topic, that is electric potential due to uniformly charged spherical cell. Suppose as shown in the figure, we have uniformly charged spherical cell. Total Q amount of charge is uniformly distributed on this particular cell. Radius of the cell, that is capital R. Now suppose we want potential at a distance small r from the center of the cell, where small r, that is greater than capital R. It implies that we want potential due to this uniformly charged spherical cell at any point outside the cell. So in previous chapter, we discussed about the electric field of this type of charge distribution. And in that, we studied this thing, this entire charge distribution behave like a point charge concentrated at the center. It implies that this entire Q charge distribution behave like a point charge at the center. So due to a point charge, the potential at a distance r, that is Q by R, or you can write 1 upon 4 pi epsilon 0 Q by R. So we can write V, that is equal to 1 upon 4 pi epsilon 0 Q by R. Clear? Now, suppose we consider a point at the surface of the cell. Then, at the surface of the cell, the distance from the center, that is capital R. So we can write the potential at the surface, that is 1 upon 4 pi epsilon 0 Q by R. Clear? Okay. Now, if we want potential at any point inside the spherical cell, means this distance R, suppose we take less than capital R. Now, up to this one, we have the work done to bring the unit positive charge from infinity to this point, that is Q by R, because that is the potential at the surface. Now, if you want to find the potential at this point, means we have to calculate the total work done in bringing unit positive charge from infinity to this point. But up to this one, we have already calculated. So now we have to calculate the additional work done to move unit positive charge from surface to this point. But now the important thing is this one. In previous chapter we studied, inside the cell, electric field is zero. So when electric field is zero, then work done to move unit positive charge from surface to any point inside the cell, that is zero. It implies that here the potential at the surface Q by R, that will remain constant up to the center. So we can say the electric potential at any point inside the spherical shell, that will be 1 upon 4 pi epsilon 0 Q by R, or we can write Q by R, for R is less than or equal to capital R. So inside the cell, at each and every point, the potential, that is constant one, and that is Q by R. Clear to all of you?